How can we see a 3D object? When we see an object, our left and right eyes see different images of the same object. This is due to the difference in viewing angle. The brain superimposes the two images together, allowing us to see in 3 dimensions. That's how we can feel depth. This is known as stereoscopic vision. To create a similar effect, 3D films are captured using 2 lenses placed side by side, just like your eyes, or by producing computer-generated images to replicate the same effect. These 2 images then superimposed on the screen. 3D glasses are used to filter these images to left and right eyes separately. Different technologies are available. Polarized 3D systems are the most commonly used 3D technology. To present a stereoscopic motion picture, 2 images are projected superimposed onto the same screen, through circular polarizing filters of opposite-handedness. The viewer wears eyeglasses, which contain a pair of analyzing filters of opposite-handedness. That is, polarized clockwise and counterclockwise. If you watch a high-definition movie, with one eye closed, you can feel the depth, and feel like 3D. A hypothesis for this illusion. Strictly speaking, seeing in 3D requires both eyes. However, depth can be sensed with one eye, as most cues to depth are monocular, that is occurring to one eye. Monocular cues that can be represented in just 2 dimensions and observed with just one eye. But watching a 2D movie with one eye closed, the brain can calculate some monocular depth cues, and feel like 3D, but limited only to -z-axis. In this illusion, the object will not pop out, because it requires binocular cues. Here, the brain fails to identify the location of objects are on the screen exactly. Due to this inability, monocular cues dominate, and a perception occurred that the backgrounds and some objects are behind the screen. If you watch 2D movie with both eyes, why can't you see in 3D? Watching a high-definition 2D movies with both eyes, the brain can spot all the pixels are on the same plane. That is, all the objects are placed on the z-axis, where value equals 0. Here, the depth perception arises from binocular cues, that are based on the receipt of sensory information in 3 dimensions, from both eyes. So the brain can calculate, all the objects are on the screen exactly. This is just a hypothesis. Please comment your thoughts, subscribe and press the bell button.